Hello, everyone. Thank you very much for having chosen this talk. I feel really fortunate. It's a great conference, and there are so many tracks and so many talks to choose. So for me, it's a real honor to be able to have such a big audience. I'm going to be talking about web performance and specifically about how we can achieve sites that load really fast and sites that are built using components. I really like the topic of performance, and I think pretty much everyone knows about how to create assets that load quite fast, like combining JavaScript or minifying JavaScript, gzipping. There are lots of typical rules that pretty much everyone knows about. But when working with components, in my case, I've been working for some time using React, I realized that there are really good things that we can achieve when working with this new way of building sites. Today, we are going to have a look at some modern libraries and frameworks that we are using for building websites these days. We will also have a look at ES6. I mean, most of you will probably know is ES6, but there's a couple of things that I think are super important. Code splitting, CSS in JavaScript, and how we can combine all of the above in order to create a site that loads really fast. And all of this also trying to survive this JavaScript fatigue that we pretty much all have. A quick couple of words about me. I'm Jose. I'm working as a senior software engineer in Spotify in Stockholm, Sweden. I'm also a Google developer expert in web technologies, and I've been working on several projects at Spotify, mostly building web interfaces. So if you use Spotify on your TV, you will be loading a web interface. If you run the web player, of course, that's implemented using web. But also if you install Spotify and you run it on your computer, that's also web, all the UI. So yeah, I pretty much build things using web. I think I'm not mistaken if I say that we like using modern tools to build our sites. Pretty much every week, there's a couple of new libraries to do UI rendering, another one for managing state on your applications. There might be a couple of new browser APIs, and it can get quite overwhelming. So, I mean, yeah, this is quite the case, right? I tweeted about this library. It's like 2 months old. It's like a React-like library that comes from Tencent, a Chinese company. And this is pretty much the case. I mean, this is 2 months old. It's already too old, right? We must be using something cooler, something from yesterday in this JavaScript world. So it's really difficult to keep up to date with everything that is going out. A couple of weeks ago, there was this report released, the State of JavaScript. It's an annual report where they ask questions to many developers. I think there were 20,000 developers that answered. And you can get an idea of what tools people are using out there, and also what tools people would like to learn. And most of these are pretty recent. Libraries like Vue.js are 3-4 years old, the same with Redux and GraphQL. So we really like using the greatest and latest. But when we pick these libraries or these different flavors of syntax, we tend to prioritize our productivity. And that's something that I'm not a big fan of. We tend to choose libraries and tools that are going to make our lives easier as developers. So we have the assumption that if we are able to ship faster, then the user will benefit in the end because they will have more features. Or if we can build more solid applications or products, then the user is going to benefit in the end. But the thing is that we don't really take into account the user when we are choosing these libraries. Do we really know what's going to be the impact when we ship this code to the user? I also think that we tend to blame the user. Um, how many of us have faced a problem with some old devices that maybe they are not running our animations smoothly enough, or maybe it takes some time to load, right? And the truth is that there might be people that can't afford any other device. Working at Spotify and realizing these days when we are launching in lots of emerging countries, and then the vast majority of users that we used to have are based in Sweden and the US, and there we have way different devices. We like pretty much everyone has a good Android phone or a good iPhone phone, and we enjoy pretty fast networks. So what happens when you release your same product in one of these emerging countries? So it's very easy to complain, but the thing is that if you care about these things, then suddenly you are going to have more access to more users. They are going to be able to use your product, and that's what we are paid for. Another topic that we like to talk about is browsers. We used to blame a lot Internet Explorer. Like there was this new browser API, and then you check the support table from caniuse.com, and it was always Internet Explorer there. That didn't support pretty much anything, right? And we've been complaining a lot. And sometimes we wonder, why doesn't the user install a modern browser? Why do I need to keep supporting them? And again, at Spotify, I'm working on the web player, and that's a product that people are using because they cannot install the desktop application. So most of the usage happens from Monday to Friday, and it's people that are working at their office or people that are studying at their schools. In most cases, they don't have any admin right to install anything. So they need to use the web version. And in many cases, they can't even get upgrades. So they are stuck using some older versions of Chrome, right? So again, we cannot assume that just because we support Chrome and we are using Chrome for developing, then suddenly our product is going to be well supported. A quick thing that I just remember, last week I was trying to make the web player renderable by Google. So Google, they have a Google bot that they use to crawl websites, and they can execute JavaScript. But the thing is that they are using an old version of Chrome themselves. They are using Chrome 42, which is 1.5 years ago. So even if you need to support, if you want to have good SEO and you are client-side rendering stuff, you need to support old browsers. In this case, because Google themselves are running an old browser for indexing. And the third field that we like to complain is network connectivity. And again, when we are working at our offices with these really fast networks, we can't really mimic what the user is experiencing out there. Yesterday, I flew from Stockholm, and I flew with Norwegian. And I really like being able to connect to the internet. But sometimes, I swear, I would prefer not to have any Wi-Fi at all. It's really difficult to navigate. Most of the times, it doesn't work properly, and it's desperate. And that's a first world problem, right? But we can imagine people that don't have access to good network speed, or even ourselves here, we are sharing the same network for pretty much everyone. So if you take care about these things, then you are going to provide a better experience. Back in the days, we used to embrace progressive enhancement, right? We did it through server-side rendering and then adding some bits of JavaScript here and there. I think we moved a lot from that way of working, and these days we are working more by defining websites using smaller pieces that we put together, components. And when I say components, I want to say it in a broad term. I'm not talking specifically about any library. So if you are a big fan of React or Vue.js, so it doesn't really matter. At the end of the day, it's a way of defining components and putting them together. You can be also a fan of web components or Preact or whatnot. There's a lot of religious people that they are like, yeah, I really like React, and you are Vue.js fun, so I don't like you, and mine is best. And it doesn't matter. So for the specifics of the web player, it looks something like this. We use components for pretty much everything. Like these days, component is not only something that paints some element in the UI. It can be the router, so the way you define how you navigate between different pages. It can be a component like a tab bar. So we have some primitives like button and link, but we don't have something a bit more complex like a tab bar. So we define ourselves. You can also compose components like high-order components, so a component that gets another component. So in this case, we have what we call a cover art, which is the picture for an album, and then we can use another component that is going to apply a lazy loading functionality, which means that that image is not going to be requested unless it's intersecting the viewport. So basically, it's within the part of the screen that the user is seeing. And if you've ever used Redux, you will be familiar. Yes, if you've ever used Redux, you will be familiar with the connect function. So again, it's a matter of adding some functionality to a specific component. In this case, it's about subscribing to a shared state and get updates whenever the state changes. Like in the old days of these single-page applications, this was pretty much how we did it. We put everything together into a bundle, and off you go, right? And you might guess what happens when the user loads this. And that will happen for a few milliseconds, or it might happen for forever if the request to that JavaScript fails. Most of these applications have a small problem. When we choose these libraries, in some cases it might be that our application code is way smaller than the library or framework code. Here I'm using framework. I know that React is not supposed to be a framework, it's a library, but then you have to pull so many other libraries within it, so in the end, it becomes a framework. But don't say it out loud. But you get the idea. Like, in the end, what you are writing is really small in comparison with what you are shipping. Users are quite afraid of these delays. And I found this report by Ericsson, where they say that pretty much experiencing mobile delays is equivalent to watching a horror movie. Well, actually, it's equivalent to solving a math problem. So, yeah, people don't like staring at their windows and, at their screens and waiting for something to load. And someone might say, I have the solution. Just server-side render it. But I think that server-side rendering a big bundle, it's a patch, but it's not quite a good patch. And I'm going to show why. So on an application where we have this big bundle that it gets client-side rendering, first we wait for the response, and then we show a blank page. We request the JavaScript and execute it, and then it gets ready. On a server-side render version of this big bundle, we are going to have to spend some more time doing the rendering because we need to fetch data, we need to return those rendered nodes. And then we are going to have this moment where it's going to be visible, but it's not going to be interactive. Then we get the JavaScript, and it gets ready. So what do you prefer as a user? Do you prefer to see a blank page or a page that looks like you can do something with, but then when you tap on a button, it doesn't do anything, right? So I think this is not the best way to fix the problem. You want to make sure that users can click and everything's going to work. So I really think that the only way forward is to break that iceberg, that big piece of ice. And in summary, serving to the user pretty much what's needed to be executed. If you've been developing websites for some time, you might be familiar with a pattern like this. You load something like jQuery, and then you need to load some jQuery UI for doing some stuff, or it might be that you want to render a map from Google Map. And of course, you need to add that script. And we normally include that, even though we don't even know if we are going to have that element in the screen. Like, it's very difficult to know exactly if we are going to have a, I don't know, jQuery UI datetime picker. So just in case, we are going to add a plugin. And it's the same with CSS. We import something like Bootstrap, just in case we need to use some of those styles. It turns out that we don't use 80% of them, but there's no easy way of specifying exactly what we need. So we didn't really have any good way of defining dependencies. Well, there was, but not that many people were using it. There was something called require.js and YUI loader, which is something I used to work at 20, and we started at some point using a loader like YUI loader, and that was a relief. But almost no one in the community was using something like that. Google and Facebook, they were developing their own tools, but they were closed source. They would talk about them. They would have the same problem. They had applications that were becoming more and more complex on the client side, and they needed to do the same thing. So welcome ES6. I think lots of people see ES6 as syntactic sugar. So instead of using var, now we can use let and const. Yay! Well, yeah, it's true. But there's more into that. So now we have a way of defining a library and exporting some functions and const. And then we are going to import some MPy in this case. We don't import something else. So we don't need that. So this, together with bundlers that know to do tree shaking, means that we can remove that code. So if you've ever used Webpack or Parcel and Rollup, which I think it was the first one that was doing tree shaking, they will be removing that. So if you think of a website as a set of pages, you can model it as a lot of imports of the different pages that you need to load, and then some code that will decide which one is going to be rendered. And this is pretty much a waste of imports. You are going to be importing everything just in case you are on that page. Something clever, more clever, would be doing dynamic loading, in which you are going to be importing dynamically, depending on what route, what path you need to load. And this is pretty much the basis of something called code splitting, in this case at the path level. So instead of having this gigantic bundle with everything, we are going to have a smaller one with some common functionality, and then we will be loading a few others as we browse through the page, through the website. So this is great, because now we can serve the code for the current path. And most importantly, and I think this is great when you talk with product managers, you can tell them that they are able to think of new features, and that's not going to have any impact in performance. So the fact that your site is 10, 20, or 30 pages long doesn't have any implication when it comes to loading the site. And we have had that problem on Spotify's web player. So the idea is going more from something like this, in which we have loading time increasing as the amount of features grows, to something more linear. So if there's a problem with one page that requires 10 big libraries, it's only going to be when you access that page when you are going to suffer from that. Very related to this is the concept of lazy loading. So we can have a page like the one on the right, and then we only load those 8 boxes. Imagine that they are images, right? Those are the only ones that are visible in the page. But what can be below it? Those boxes can be images. They can be text that is using some custom web font. So you don't request that custom web font unless that code is rendered. Sorry, unless that text is rendered. Or it can be some other component. So pretty much you can lazy load anything, not only images. So this is even greater. instead of just serving the code for the current path, we can serve the code for the current screen. Before I was mentioning browser support, and a way of supporting old browsers is by adding polyfills. Polyfills are good, but normally it implies that you are going to penalize users that are using a modern browser, because even if they don't execute that polyfill, they will need to download it. So we can apply lazy loading also for polyfills. So in this case, I'm going to be importing something called intersection observer. So intersection observer is an API, a browser API, that allows us to implement lazy loading in a very good way, in a very clean way. We can subscribe to elements, and we can say, when this element is within the viewport, let me know, because I'm going to do something, maybe requesting an image. So in this case, we can detect if intersection observer is defined, and if it's defined, then we resolve the promise. Otherwise, we are going to import a polyfill, right? And I'm going to show an example of this. So imagine this page where we have a page that doesn't load anything here on the network, and then when we scroll down, it's going to lazy load that Google map. Right? So that bunch of requests are not needed if the map is not on the screen. So something like this on Safari, which doesn't support intersection observer, results in an extra request, which is going to be the polyfill. Right? So we can see that bundle splitting can be helpful in some other use cases, like polyfills. So not only you can serve the code for the current screen, but also for the current screen, the current browser. So again, serving only what's needed. I've been talking the whole time about JavaScript, but there's also a big chunk of code in the shape of CSS, which has been super painful to split until recently. So whenever we try to break down the CSS and do something like lazy loading, we were going to have a problem if we try to apply styles to some elements that were already rendered. So when you lazy load JavaScript, you can execute it when it comes, and that's all great. But when you lazy load CSS, you might incur in problems with flash of unstyled content. So you see some elements there on the screen, and then as soon as the CSS comes, then it changes the shape, it changes the design. And that's not something that we want. I don't know about your idea on CSS in JavaScript. When I first saw it, I wanted to scream. It's really ugly, to be honest. It's something like this. So you import, there are many libraries, but the whole idea is to import a function, and then you pass some object, or in this case, a piece of text with the CSS style, right? And yeah, when I saw it, it was pretty much like the first time I saw React and using JSX within JavaScript. It's like separation of concerns. You're mixing everything together. That should be forbidden. And we got used to that, and it made sense. You could define a component, and a component could be some template and its associated logic, which is great. So in this case, we can do the same with CSS. And what I want to explain is that this specific component that can be, it's a modal box, it has its associated CSS. And that CSS is not going to be included unless we show a modal. So it's a very good way of splitting the CSS, right? Instead of importing that big styles CSS that will contain those styles, it's going to be collocated to that component. So we can go from something like this to something more like this, where we have the bundle splitting that I explained before, but now we also have chunks of CSS within it. And this is really amazing. You can serve the code for the current screen and browser, but it's better if you can really really break that behemoth of CSS and JavaScript that we normally use on our sites. So I'm going to wrap up. I went through JS fatigue, and to be honest, I don't have so much free time as I used to. I thought that people were, I don't know, like they had to spend some time on some side projects and investigate. And I got a baby a couple of years ago, and I don't have that much time. And for me, it's getting a bit frustrating not to be able to follow up everything that is going on. And it produces me some fatigue sometimes. But I think if you see all these new libraries as tools and you apply them, you understand more or less where they fit, and you add them to your toolbox, and then you see the big picture, you start seeing nice ways of putting them together. So something like CSS in JavaScript, some people might say, oh, that's only used by people who don't really understand the cascade, who don't really understand CSS, who hate it. But then, if you put it together with bundle splitting, now you have a good solution for a problem that affects pretty much every single page application. So, yeah, basically, don't see it as JS fatigue. Try to see it as a tool and use it whenever it's needed. And that's all from me. Thank you very much. And since I thought I was going to be talking for longer and we have some time, I'm open for questions.
Hi, thank you for the talk. I think it was really good. But I have some questions, just about the CSS in JavaScript. The first, yeah, thank you. The first thing is I was thinking about when we change the CSS, adding a new class, or just overwriting the existing CSS. For example, when we put active in a div, in an element, in a component, my first question is, how easy is to overwrite the CSS if we put the CSS inside the JavaScript?
I think it's very easy. You deal with changes in state the same way you deal with the output HTML. So if you are using React, for instance, you get some props, and then you are going to change what you are going to render depending on that state. And if you think about it, normally you change the CSS also based on that, on some change in the state, in the properties. So it's really easy. You just model it based on the properties that you are going to be getting. At the beginning, there were some issues with things like hover, which wasn't very easy to define, or media queries. That wasn't very easy to define using this. But these days we have, that's been solved by all these tools.
Okay, another question, if you don't mind. In your experience, how this way to code the styles inside the JavaScript code works with the reusability of the Java of the styles? For example, maybe if you decide to code a way or a grid in CSS, and you see that you put that, well, how explain? Sorry, a moment. Did you find that there is a lot of repetition in the CSS code when you put the CSS code inside the JavaScript? Like 3 developers has code 3 different ways to put a grid on the elements inside a component, for example?
Yeah, we've run that. We've run through that. Also, we were at the beginning we were experimenting with different CSS and JavaScript libraries and different ways of solving it. Like we tried with CSS modules, so we have part of the code that is using that. We were using Styletron. We've been also using style components. We have used different ways of defining it. But I think it pretty much works as long as you agree with the team on using a certain way of working. You can also isolate certain behaviors. Like if you have a model like this where you normally have a position absolute and then top 0, left 0, you can you can have that as part of a library, and then you can import it and add it to your element. So you can also export some behaviors that you normally in CSS repeat, or I mean in CSS you should be, if you don't want to repeat it, then you should create some other class name, and then your element will have 2 different class names. So you can have the same behavior pretty much in JavaScript. And the good thing is that, well, the good thing, these tools abstracts you from the class names. So it's going to have, imagine that you have a div and you say, okay, these are the CSS properties that I'm going to add. These tools are smart enough to see some repetition there, and they might create 3 or 4 different class names. And the good thing is that they are very short class names, so that helps with the payload size. The bad thing that I really hate is that it's very difficult to debug. So you don't really know where something is coming from. So if you're used to find a class name using the inspector tool on the browser and then go into your code base, you don't have that mapping anymore. And that's quite painful. It's one of the downsides of these tools.
Okay, thank you very much.
Thanks to you.
I have 2 questions. One of them is how much Redux can affect the performance in a complex application? And what about the use of something and defer during the loading of the file is really change the performance time?
We've been using Redux for, especially for the web player for a long time, and there's a downside when you do code splitting and you take an application and you split the JS bundle into smaller chunks, but then you're using Redux and you want the shared state. Redux it gets a bit tricky if there's no easy way to break a reducer. So you might end up with a situation where you have big reducers and middleware because you cannot break them down and in a so easy way. So specifically on the web player, we have a shared state where every entity that you load gets there in Redux. In that way, you can navigate between different pages and you can see the page loading very quickly because we already have some data pre-cuts. But if we apply lazy loading and bundle splitting, we still have that big reducer middleware that we don't have any way of breaking down. We have something called entities reducer, which is a 1,000 lines of code. And we've been discussing different ways of breaking it down, and it's not that straightforward. So that's a problem. And then to your second question, we have, I think, if you search for web performance optimization, you will see lots of different research out there by companies that have been seeing a correlation between traffic that is sent down, like payload, and user engagement. And in Spotify, we then believe that, I guess. And in every company, they're like, yeah, but those are metrics from some other company. Like, do we really know if that also applies to us? And we have a couple of teams that have been experimenting adding delays. We can see that if you add a delay either when the user is trying to play music or when the application loads, they are going to be playing less music afterwards. So we do see their correlation. So these might not seem important to us. I mean, we need to care about so many things. It's like I can come here and tell you about how important accessibility is. I can come here and tell you how important it is to follow nice design guidelines, and everything seems important these days. So I think performance have a direct impact on key metrics that businesses care. And that's why I think we have a way to, if we really care about this and we really believe in that, we have a way forward. We have the good tools and metrics to convince our companies to care about these things.
Thanks.
Hi, Jose. Thanks for your talk. I got a couple of questions. First one is, have you tried, as long as you said that you were using ES6, have you tried string literals for CSS instead of using CSS in JS, using string literals? String literals.
String literals.
Yeah. String literals from.
No, we haven't. We've been trying style tron and
No.
CSS modules, but
No, I mean,
string literals for
yeah,
templates
it's
or for CSS.
for CSS instead of having CSS in JS.
Yeah.
What you do is you generate a string literal that will output a CSS.
We haven't.
Okay.
Yeah, we haven't tried that.
Okay, and the second question is that you didn't talk anything about Shadow DOM for CSS. Do you use Shadow DOM or?
When we started this project, the project I'm working on is around 3 years old, and the whole company has been pretty much adopting React. So I personally had a look at web components. I'm a huge proponent of using standards if we can, but web components have been taking a bit of time to get adopted, and especially because of the browsers that we need to support, we didn't have a good way of using Shadow DOM, for instance. I know that these days you can use not React, but there are some other libraries that you can decide if you want to output one of these components, like a React or Vue.js like, or you can also output a web component. And in that case, you can have a Shadow DOM, and you can also specify a CSS there, so you can isolate it from the rest. We are not using web components at Spotify as far as I know. But I hope that, I mean, now there's a good support. Now I don't know if I would take the same decision, seeing that there's a greater adoption, and also we've been removing some old browsers. We stopped supporting I11, which was a bit painful in that sense. So it might be that now, if we had to make the case, we would use web components instead. But we've been using React.
Okay, thanks.
Hi, I wanted to ask about a very specific technique that I've seen used in many websites. For example, the Slack website, when you load it up at first, you don't see the actual conversations, but you see like small blocks rendered that look just like conversations, but they're just like CSS boxes. So do you know what I'm talking about? Does this have a name, and how do you go about implementing that?
That's called, I think it's called skeletons, skeleton UI. I saw recently a post talking about that on, I think it was CSS Tricks. There are ways to do it using CSS and gradients, something quite weird. And you can also use it, you can implement your own React components that say, if I don't get anything, then I'm going to render these SVGs. So I personally like that solution because I've been investigating a bit on loading images and using placeholders and rendering something in the placeholder until the image comes. And this is a very similar situation. If you give something to the user while you are fetching the data, then the user is going to feel that there's something ongoing. So that's something that lots of sites are using, in applications. If you open Facebook, for instance, you can see there. Sometimes they also have some animations from left to right. You see the gradients changing. So apparently that improves the user perceived performance of your site. And yeah, the same way you create components, React components for imagine like an image or some text. Within that same component, you can decide what to do if you don't get anything, or define some kind of loading state, and then say, if I'm loading, then I'm going to render this, and when I'm loaded, I'm going to render what I finally got. So again, you can isolate that and put that code into a component.
Understood. Thank you.
Hi.
Hi.
Recently, we started a project in Spot@Home to using styled components. So we have a little bit experience, use some weeks. And the question is, there is any issue for big apps using styled components? Did you find any issue rendering in the client side?
Not so far. Not so far. Most of these solutions are pretty much equivalent. If you compare amongst them, there are some performance benchmarks that they are going to run operations like, I don't know, thousands of operations per second. But in reality, your bottleneck is normally somewhere else. I wouldn't worry so much about the performance of using these libraries or one of the specific CSS and JavaScript libraries against another one. Normally, they are really quick. And if you're having performance issues, they live somewhere else. They normally live on React because you are doing something wrong there.
Okay. And I have another question about the server-side rendering. You are encouraged that the server-side rendering is only for SEO, but not for the user experience.
Yes and no. Like, as a user, I like to see things on my screen happening early on, but I also want to be able to interact with them. So I think it's a better experience having it there as long as the user doesn't interact with it. So you have to hope for the best. I guess it also depends on how many interactive elements you have there. So for you, it might not be a problem. And it might be, for instance, that you use it for, you could have links that behave like links, but then when you render them client side, when you get that JavaScript and it executes and it adds the event handlers, it might be that instead of a regular navigation, you are going to do one of these navigations in page where it fetches the next page synchronously and then it changes it there. You don't see a whole reload, which would be like doing a progressive enhancement. So if you are able to do something like that, then there's no need to care. There's a case study. There's an example by Netflix in their sign-up form, which went quite viral recently, where they stopped using React for doing the rendering of that. And basically what they did was doing progressive enhancement. So they are still doing React on the server to render it, but then if you have a form, like this was a sign-up form. In the end, it's a matter of inputting some fields and clicking on a button and then it submits. We've been doing this for ages without React or anything like that. You don't even need JavaScript for that. So it works without JavaScript. And then when they get the JavaScript, it attaches some behavior and it will still work. But the idea is that if your app really depends, or your web app really depends on that JavaScript, then you might have that issue that the user tries to interact and it doesn't work.
It depends on the use case, no?
It depends on the use case, yeah.
Okay, thanks.
No problem. I think what I want to encourage is that shouldn't be the first solution to think of.